This is Practical 9, Packet Tracer Activity, Examine the ARP table. So there's 3 objectives in this activity. Part 1 will be to examine an ARP request. Part 2, examine a switch MAC address table. Part 3, examine the ARP process in remote communications. Background. This activity is optimized for viewing PDUs. The devices are already configured. You will gather PDU information in simulation mode and answer a series of questions about the data you collect. So if we jump straight into it, Part 1, examine an ARP request. Step 1, generate ARP requests by pinging 172.16.31.3 from 172.16.31.2. A. Click 172.16.31.2 and open the command prompt. So we'll go to desktop, command prompt, and part B says enter the ARP -d command to clear the ARP table. So just pop that in here. Next we will do part C, enter simulation mode and enter the command ping 172.16.31.3. So in simulation mode. Two PDUs will be generated. We can see them here. The ping command cannot complete the ICMP packet without knowing the MAC address of the destination. So the computer sends an ARP broadcast frame to find the MAC address of the destination. Click capture forward once. We can see the ARP PDU moves to switch 1 while the ICMP PDU has disappeared, waiting for the ARP reply. Open the PDU and record the destination MAC address. Okay, so let's open the PDU. You can see here, and if we check here, and it says, is this address listed in the table above? So if I just go back quickly to our table above, we can see that no, it is in fact not listed. Okay. Click capture forward to move the PDU to the next device. How many copies of the PDU did switch 1 make? Okay. So we can see there's 3 copies, 1, 2, and 3. What is the IP address of the device that accepted the PDU? So we can see this device accepted the PDU here, and its IP address is 172.16.31.3. Open the PDU and examine layer 2. What happened to the source and destination MAC addresses? So let's have a look. We can see source became destination address. The F address turned into MAC address of 172.16.31.3. Click capture forward until the PDU returns to 172.16.31.2. How many copies of the PDU did the switch make during the ARP reply? So let's just... And we can see here that 1 copy was made. Step 2, examine the ARP table. A. Note that the ICMP packet reappears. tricky note. Open the PDU and examine the MAC addresses. Do the MAC addresses of the source and destination align with their IP addresses? So we just check here, and yes, we can see that they do align with their IP addresses. Switch back to real time and the ping completes. Click 172.16.31.2 and enter the ARP-A command. To what IP address does the MAC address entry correspond? Let's go ahead and open this. So we just enter ARP-A command. And we can now see the corresponding IP address is 172.16.31.3. And part D, in general, when does an end device issue an ARP request? When it does not know the receiver's MAC address. On to part 2, examine a switched MAC address table. Step 1, generate additional traffic to populate the switched MAC address table. From 172.16.31.2, enter the ping 172.16.31.4 command. 172.16.31.4. Click on 10.10.10.2 and open the command prompt. Enter the ping 10.10.10.3 command, and we will check how many replies were sent and received. We can see the answer is 4 sent and 4 received. Step 2, examine the MAC address table on the switches. So in A, click switch 1 and then the CLI tab. We'll enter the show MAC address table command. Do the entries correspond to those in the table above? So we'll just have a quick look at our table. And from inspection of the table, we can see, yes, they do correspond. Part B, click switch 0, then the CLI tab. Enter the show MAC address table command. Do the entries correspond to those in the table above? We can see, yes, that they do correspond. Part C, why are 2 MAC addresses associated with one port? Because both devices connect to one port through the access point. Part 3, examine the ARP process in remote communications. Step 1, generate traffic to produce ARP traffic. A, Click 172.16.31.2 and open the command prompt. Enter the ping 10.10.10.1 command. Type ARP-A . What is the IP address of the new ARP table entry? And we can see here, this is the new MAC address. And here is our new IP address, 172.16.31.1. Enter the ARP-D to clear the ARP table and switch to simulation mode. Repeat the ping to 10.10.10.1. How many PDUs appear? And we can see that the answer is 2 appear. Click Capture Forward. Click the PDU that is now at switch 1. What is the target destination IP destination address of the ARP request? And we can see the answer is 172.16.31.1, which is router 1. The destination IP address is not 10.10.10.1. Why? The gateway address of the router interface is stored in the IPv4 configuration of the hosts. If the receiving host is not on the same network, the source uses the ARP process to determine a MAC address for the router interface serving as the gateway. Moving on to step 2, examine the ARP table on router 1A, switch to real-time mode, click router 1 and then the CLI tab. B. Enter privilege exec mode and then the show MAC address table command. How many MAC addresses are in the table and why? The answer are that there are 0 MAC addresses in the table, as this command means something completely different than the switch command show MAC address table. Now enter the show ARP command. Is there an entry for 172.16.31.2? And we can see, yes, there is. What happens to the first ping in a situation where the router responds to the ARP request? Well, it times out. And that concludes this activity.